Welcome everyone to the 17th video in a series of videos on solar and wind energy estimation and forecasting application developed in MATLAB. I'm Kiran Gaikwad, the developer of the application. I have a Master's of Technology in Power Electronics and Power Systems from Sardar Patel College of Engineering, Mumbai. I'm currently working as a Junior Project Fellow at GERMI, Gujarat Energy Research and Management Institute, under Dr. Sardar Agrawal. In this video, we will discuss about the forecasting application. It has the following sub-applications: ARIMA forecasting app, ANN forecasting app, and the WRF NETCDF forecasting app. In this video, we will be discussing about the WRF software package and the NETCDF file extraction and visualization app. WRF, or Weather Research Forecasting System, is an entire software package for performing weather analysis and prediction on test as well as real cases. It has been developed by collaboration between NCAR, that is, National Center for Atmospheric Research, NCEP, that is, National Centers for Environmental Prediction, and a bunch of other research institutes, all based in the USA. The figure here shows a complex schematic of the component softwares of the WRF package. But this figure illustrates a simple schematic of the workflow and software components involved in performing a real case weather prediction simulation using WRF. The WRF software package is divided into two major parts. Firstly, the WPS, or WRF Pre-Processing System, and secondly, the WRF, or the Weather Research Forecasting System. The WPS is composed of three softwares: ungrip.exe, geogrid.exe, and medgrid.exe. Ungrip.exe reads weather data grip files and ungrips them into a simpler intermediate format. The geogrid.exe interpolates terrestrial data to simulation domains. Medgrid.exe horizontally interpolates the intermediate format meteorological data extracted by ungrip.exe to the simulation domains defined by geogrid.exe. The custom run can be controlled using the namelist.wps file. The main function of WPS program is to pre-process weather and terrestrial data into a format which can be used by the WRF system. The WRF system is composed of two softwares, real.exe and wrf.exe. The real.exe converts the output files from the medgrid.exe into an intermediate format which can be used by the second WRF program. The WRF.exe is a numerical integration program which solves partial differential equations of the atmospheric and oceanic processes to compute weather forecasts. Bash scripts have been written to download the initialization weather files from the web and run WRF and WPS softwares interactively in an automated manner. Moreover, the data visualization and extraction app helps in visualizing and extracting the output variables from the WRF.exe into Excel files. The WRF systems are traditionally run on computer clusters or supercomputers due to the intensive computing required. The figure here illustrates a simple 4-node cluster created from Raspberry Pi 2s as an economic way to provide the WRF system a clustered environment so that it can be used more efficiently. The 4 Raspberry Pis are connected to the network switch via LAN cable and powered by USB hubs. The workstation is also connected to the network switch via LAN cable. The WRF sessions on the Raspberry Pi cluster is controlled remotely from the workstation. These images show the actual cluster setup on my desktop at GERMI. This is WRF NETCDF app window. It is used to visualize the WRF output file variables and extracting the same into Excel files. That is all about the WRF software, Raspberry Pi 4 node cluster, and WRF NetCDF app. Let us have demos and see everything in action. Thank you.